Hi, this is Dr. Xu, teaching mine ventilation for mining engineering college students. In this video, I will show one example of performing gas simulation in VinSim. We will use methane emission in a coal mine as the example. During the formation of coal, water, carbon dioxide, and methane are formed. If coal is buried deep in underground, a lot of carbon dioxide and methane can be trapped in the matrix of coal, and the gas content can range from 1 cubic meter per ton of coal to more than 18 cubic meter per ton of coal. When we mine the coal matrix is released from the high ground pressure, and the trapped gases in coal will be released. The total amount of gas that can be released under normal temperature and pressure can be measured using the methods shown on this slide, and we call this amount the total desorbable gas content. Most of the cases, gas desorption process is a slow process. In a longwall mining system, gas is continuously released to the longwall face from the time that the ground stresses on coal is released due to mining. This is a hazard, as methane is an explosive gas. The gas emission rate can be estimated if the coal production rate is known. For example, if the total desorbable gas content, TDGC, is 8 cubic meter per ton of coal. For simplicity, we just assume all the gases are methane. So it is a pure methane. Although most of the cases it's a mixture of CO2 and CH4. The longwall face production rate is 8,000 ton per 8-hour shift. Assume 10% of the total desorbable gas content in the cut coal will be released to the longwall before coal is transported to surface. This is because gas is releasing slowly, and the coal will be transported to surface. Once the coal is on the surface, it won't pose any hazard to underground. So from the time the coal is cut to the time that coal is transported to the surface, in this problem we are assuming 10% of total desorbable gas content is released to underground. So now we can calculate the methane release rate. We are producing 8,000 ton of coal per 8-hour shift. And within that 8,000 ton of coal, there is 8 cubic meter per ton of methane in it. So the total amount of methane is 64,000 cubic meter. Out of that, 10% of that is released. So that is 6,400 cubic meters. And 6,400 cubic meters of gas is emitted over a period of 8 hours. So normally we convert it to seconds. So 8 hours by 3,600 seconds per hour. So that gives us 0.222 cubic meter per second. Well, normally we quantify the gas emission rate in liter per second. So that equals to 222 liter per second. We can then apply this emission rate to a VinSim model and simulate the concentration of that gas in an airway. If we assume here is a longwall face, we can apply the gas emission rate there. So go to that airway, click Edit Airway, click the airway that we want to apply the gas emission, click this gas icon, and from here I want to create a new gas mixture. So I will just call this gas mixture as pure methane. And it's going to be 100% of methane. Depending on the real gas mixture concentrations, you can create different types of gas mixtures. In this example, we are just using pure methane. Click OK. Now you can select the gas mixture we just created, so pure methane. From the calculation, the emission rate is 222 liters per second. Because the mining process is mining back and forth, it is a linear emission. So in this case, we apply this linear emission. Sometimes it is a point emission. In that situation, you do not need to select this linear emission. And the unit here is liter per second per 100 meters. So the total rate is 222 liters per second, but this airway is 200 meters. So per 100 meter, it is half of that. So 222 divided by 2, that's 111 liters per second per 100 meters. Apply and simulate. Okay. Go to here, select gas, and go to here, select CH4. And now you can see the methane concentration at the longwall phase is 0.42%, which is okay because most of the time, as long as it's less than 1%, it is safe. If this concentration is too high, there are two ways you can reduce the concentration. Number one is you can increase the airflow at the longwall phase. You can do it by either further restricting air come from this airway, so you can push more air to the longwall phase, or you can put a more powerful main fan on the surface, and the result of that will be more air will be provided to the longwall phase. Okay, that's the video for today. Thank you very much for watching. If you feel this video is useful, please like and subscribe my channel. Share it to your friend who may also benefit from this video. I'll see you next time.